In the second talk on effect modification, I'm going to be showing you how to use a second method of assessing effect modification. And that's the method of comparing the observed and the expected effect estimates, or relative risks, or risk differences. And this is where we compare the observed for the joint exposure to what we'd expect in terms of the risks associated with the two exposures occurring separately, and we'll show you how to do that. Again, we're going to use the laryngeal cancer example, laryngeal cancer in alcohol, and the effect modification by alcohol, by cigarette smoking, sorry. And we're going to look at three things. We're going to look at additive interaction on an additive scale, multiplicative interaction on a multiplicative scale, and, perhaps surprisingly, we're going to talk about how we can assess additive interaction on a multiplicative scale. So here's our data. Now these data are what you have seen before, and this is simply the stratified data, stratified in terms of non-smokers and smokers. So and the S refers to smoking or not, S minus non-smoker, S plus smoker, A minus non-drinker, A plus alcohol drinker, D minus for disease, non-case, D plus laryngeal cancer case. So that's the terminology we're going to be using. So we take these data and we convert them into cumulative incidence rates. So I've color-coded it here so that you can see how it works. So basically we construct a new 2x2 table, and it shows the distribution among the four categories of alcohol consumption and smoking. So here we have S minus, A minus, non-drinkers, non-smokers, and we've calculated their the cumulative incidence. It's 6 cases divided by a total of 156. And we do that for all of the four categories, including people who both smoke and drink. And so it comes from here. We have 26 cases divided by the total of 147 in that category of alcohol drinking smokers. So we do that. Those are the fractions, and those are the decimal figures. And so we use those to work with. Right. So the next step is to set those out in terms of a slightly different arrangement here. But basically just a rearrangement of the data in that 2x2 table. Smoking and alcohol, the four possibilities, and the various cumulative incidence measures from that 2x2 table. So we can say that from the group of the group of people who smoked and drank, that their observed cumulative incidence is 0.177. So there we have it, we have the observed. So then the question is, how do we get the expected to compare with that? So basically we have to add this value for alcohol drinking non-smokers, and this value for smokers who don't drink. We start by adding those two together. But then we have the problem, we have two baseline risks, because both this group and this group here, they can actually contain this baseline risk. So there is some risk associated with being neither a smoker nor an alcohol drinker, and that applies right across every stratum. And so we basically, and it is contained within this value for non-smoking alcohol drinkers, and it's also contained within this value for non-drinking smokers. So if we just add these two together, then we have two baselines, twice this value incorporated in there. So we basically have to subtract it once. And really that's what this slide here is saying. And you do it if you have cumulative incidences, as we do in this instance, or if you have incidence rates, incidence density measures. So here's the calculation. Basically we add this with that, and we subtract one baseline measure, because we already have a baseline measure in there, and we get 0.094. So this is assessing effect modification on an additive scale, and we can say, because we compare the observed value with the expected value, and the observed is greater than the expected, so it appears we have synergy on an additive scale. Again, so the expected value is less than what is observed in practice in people who both smoke and drink alcohol. Therefore, we have synergy on this additive scale. Additive scale being signified by use of cumulative incidence measures. Okay. The next step, we want to convert these rates to ratios. So we take those cumulative incidence rates, which you saw a few slides ago, and we convert these to risk ratios, also known as cumulative incidence ratios. Okay. So it's very simple. We use the non-smoking, non-drinking group as our baseline. So we divide each of these measures by our baseline. And we divide the baseline by itself, and we get 1. And these are the fractions that we get. And then divide it, and we get this. And so the baseline is 1, and all these other measures, other risk ratios, are relative to this reference level, this baseline measure. So, okay. So now we want to look at how we can evaluate multiplicative synergy synergy on a multiplicative scale, I should say. Okay. Again, we set things out in this slightly different arrangement, and these are the data we had before. So we now have a new column, or 2 new columns. These are the observed relative risks, calculated from exactly the same data. Now again, from our study, we have the observed relative risk for the combined effects of smoking and alcohol. So the relative risk ratio of 4.66. So the question is, what do we compare it with? What's the expected relative risk on a multiplicative scale? So it's fairly straightforward. We multiply this value for the alcohol consuming non-smokers by the value for smoking non-alcohol consumers. So we just multiply these 2 relative risks together, and that will give us our expected value. You might ask the question, what about the baseline risks? Well, there is no problem with them. We don't have to subtract any baseline risk here. If that troubles you, you can think about it, the equivalent would be to divide by a baseline risk. In other words, to divide by 1, which of course makes no difference, but that would be the equivalent of subtracting 1, or subtracting the baseline in when we're looking at effect modification on an additive scale. Okay, so we multiply these 2 together, as here, and we get 2.96. So we compare our expected value for the joint effect of smoking and alcohol with the observed value for the joint effect of smoking and alcohol. And you can see, once again, the observed value is more than the expected. So we have synergy. So we have synergy on a multiplicative or a relative risk scale, whichever you prefer to say. So the 2 scales are effectively consistent in terms of they both show evidence of synergy. The third method, which is less intuitive, is to compare the observed and expected using relative risks, which of course are on a multiplicative scale, to assess additive interaction or additive effect modification. So again, we set out the data, and again we have the same observed value. So how do we get the expected value for this combined effect? Basically, we add this value, 1.97 and 1.50, but again we have the problem of the double baseline. So again, we have to subtract 1 baseline. So very similar to the way we did it on an additive scale, we subtract 1 baseline. So here we have it. We add the 2, 1.97 plus 1.50 minus 1 gives us 2.47. So again, we compare the expected and the observed, and we see that the observed is higher than the expected for the joint effect of smoking and alcohol. So again, we see that we have synergy on the additive scale. On an additive scale, assessed using relative risks. And relative risks, of course, are usually considered to be on a multiplicative scale. The two methods for assessing additive effect modification are basically exactly equivalent. If you find synergy on one scale, by using one method, you'll find it using the other method. And if you find antagonism using one method, you'll find it using the other method. And basically, there's a simple equivalence of the two. If you multiply the expected relative risk by the baseline cumulative incidence, you will get the cumulative incidence using the other method. So the two are exactly equivalent, and this third method, assessing additive effect modification using relative risk measures, is particularly useful with case control studies. So in my next talk, we'll be discussing case control studies and how to assess effect modification in them.